Hi, I'm Miranda Cosgrove, and this is Mission Unstoppable. Coming up, don't forget to watch this segment on memory.
I was thinking maybe I'd test your memory today to see how your brain's functioning. What do you say?
I hope my brain is working properly.
Then, can a math equation prove aliens exist?
Aliens, if you're watching, send an email or something. I really want to hear from you.
And find out what animals are making secret sounds.
It turns out that giraffes actually hum late at night.
Plus, see how STEM helps explorers to discover our world.
What I love about our explorers is that their courage really comes from curiosity.
Get ready to meet the scientists, inventors, and heroes who help make our world a better place. The future is here. The mission, unstoppable. Remember that segment we had on learning about memories? Probably not, since we haven't done that yet. But you will soon. Take a look.
Over the course of human history, science has taught us a lot about our bodies. Your skin accounts for 16% of your weight. You're 1 centimeter taller in the morning than you are at night. And your sneezes can come out over 100 miles an hour. Thanks, science. But when it comes to the inner workings of the human brain, there's a tremendous amount left to learn. One science dedicated to unlocking some of the mysteries of the brain is neuropsychology, which studies the relationship between human brains and our behaviors. Neuropsychologists, like graduate student Marina Nakhla, study memory hoping to identify early signs of dementia, Alzheimer's, or Parkinson's, and understand how the brain changes with these diseases.
What I love most about my work is that I get to work with people on applying skills that can help improve their mood, that can help decrease some anxiety, that can help them, have a better life overall.
So I head to San Diego to learn more. But first, Marina has another idea.
I was thinking maybe I'd test your memory today to see how your brain's functioning. What do you say?
I'm down.
I may not have Alzheimer's, but I do have a memory. And Marina's research studies brains of all ages to help map out what's normal brain behavior and what's not. At the first station, I look at an image for 30 seconds, then try to recreate it from memory.
Okay, now flip it over.
Okay. Here we go, Nabeel. Ooh, and then these parallelograms. Okay, and there, I'm done.
Okay, now we move on to station 2.
Wait, you're not gonna tell me if I'm right?
I'll give you feedback at the very end.
Spoken like a true scientist. So I press on to station 2 and name as many of the 50 states as I can.
Alabama, Alaska, Arizona, Arkansas, California, and Minnesota, Mississippi, Oregon, Pennsylvania, Rhode Island, South Carolina, West Virginia, Wisconsin, Wyoming.
Great.
Woo!
Anything else?
States of confusion? Because I'm definitely in one right now.
At station 3, I pick 2 cards from a deck and try to memorize them.
The 5 of Hearts, the King of Clubs.
Then it's on to the last station, identifying items I can buy at a grocery store.
I don't know what this is, but it looks like a vegetable. Some green grapes. Get that at a grocery store. Okay. I think I feel good about that.
Okay, great. Now, do you remember the 2 cards I asked you to recall earlier?
They're the 5 of Hearts and the King of Clubs.
Okay, great.
The tests Marina just put me through checked my declarative memory. This conscious form of remembering can be broken down into 2 categories, episodic and semantic memories.
So episodic memory is particular to specific episodes.
For example, I remember that I had a stack of pancakes this morning with maple syrup. That would be an example of episodic.
Yeah, and it sounds delicious. Semantic memory is information that you've accumulated over a lifetime.
Like, I know that an ocean is a body of water, but I don't really remember when I was taught that.
Yeah, exactly.
So at station 1 and 3, I was being tested on my short-term episodic memory. Being asked to name the 50 states, however, is a semantic memory.
I was taught the 50 states in alphabetical order as a kid, and I don't remember exactly when I was taught that, but I was able to recall them pretty easily, I think.
You did pretty good, actually. I think it was easier for you than maybe most people.
Station 4 was another semantic memory test with a little twist.
This is more of a recognition task because you're not asked to just say them from memory, you're asked to pick them out.
How'd I do?
Looking at other people in your age group, you're doing in the average range, which is exactly what we want to see.
Marina and fellow researchers hope that by understanding how brains in different age groups respond to these memory tests, they can identify and study irregularities that could dramatically change how we treat aging memories.
I will never forget everything you taught me today.
I hope not.
All right, thanks so much.
Bye.
In my dressing room between takes, I like to check in with our experts. So I asked Marina what she's been up to since we last filmed. Check it out.
Hi, Miranda. Since I last filmed with you, I've been busy defending my PhD and working towards getting my license by doing a clinical internship. My clinical psychology work mainly focuses around US veterans. I really love working with veterans because I feel like they've sacrificed so much for our country and for our safety here. Being a child of immigrants, I've always been really grateful to be born in the US, and I just want to give back to the community. And I want to help empower them to take care of both their physical and mental health. I love hearing their stories and giving them tools that can help them advocate for themselves so that they can build their own support system. And for all of you viewing at home, just know that everything is possible and keep dreaming big. Bye.
Sometimes math can help you solve for the hypotenuse of a triangle. Other times, it can help you solve for the number of alien civilizations in the universe. Astro Athena can tell us more.
Finding life on Earth is easy. Look around. There's a plant. There's a bug. Oh, there's Gary. But finding life in space is really hard. Are there even other life forms out there? Hi, I'm Athena, your friendly neighborhood astronomer. And today, I'm going to tell you all about the Drake equation. It's sometimes called the second most famous equation in science, and it's named after this guy, Dr. Frank Drake. The Drake equation gives us an estimate of how many other intelligent civilizations could exist here in the Milky Way galaxy. So let's break it down. We start with this guy, N. It stands for the number of technologically advanced civilizations in the Milky Way galaxy. But if we want to figure out N, we need numbers for all these other variables here. R stands for the rate in which sun-like stars are forming in the Milky Way galaxy each year. In 1961, Drake and his colleagues thought a conservative estimate for this was 1. Nowadays, the scientists think that R is more likely between 7 and 13. The middle part of the equation all represent fractions of numbers. FP is the fraction of those stars that have planetary systems, meaning more than one planet orbiting around them. And NE refers to the number of planets per solar system with an environment suitable for life. These are also known as habitable or Earth-like planets. And not to brag or anything, but Earth is probably the most well-known Earth-like planet out there. The terms FL and FI stands for the fraction of those life-supporting planets that actually develop life forms, and the fraction of those life forms that are intelligent. Intelligence might be super rare. Even on Earth, where billions of different species have existed, only humans have evolved to the type of intelligence that we're looking for. I know elephants, dolphins, and pigs are all super smart, but they're not sending out radio signals to space, which is why scientists also factor in the next integer, FC. That considers the fraction of intelligent life that is able to send out communication that we can detect back here on Earth. Last but not least, L. This term represents how long, in terms of years, an advanced alien society would be around to send signals into space. According to Drake, when we multiply all this together, we have an estimate for the number of technologically advanced civilizations in the Milky Way galaxy. When they ran this equation back in 1961, they calculated that in our galaxy, there should be between 1,000 and 100 million planets with intelligent alien civilizations. Okay, so why can't we see them? Well, for one, we've only been sending out radio waves for like a century. And those waves are not necessarily designed to be picked up by aliens. Other civilizations could have the same issue. Take a look at the galaxy. Here's the square where our radio waves have traveled. if someone was looking for us, we'd be pretty hard to find. Another thought, one that just totally boggles my mind, is that Drake's equation assumes other advanced civilizations will need food, water, sunshine. But what if none of these factors are necessary? What if on Neptune, there's some sort of rock-like alien hanging out in the methane atmosphere? Drake's calculations may not account for this possibility, but my imagination definitely does. So, aliens, if you're watching, sound off in the comments or send an email or something. I really want to hear from you. I'm Athena, your friendly neighborhood astronomer. Always remember, per aspera, ad astra. Bye, guys.
Our human ears are amazing and the perfect place to put earrings. But they have their limits. Check it out.
Animals make a lot of noise, especially birds around 5 a.m., though I try not to take that too personally. Now, what if I told you that there's an entire world of animal sounds that we simply cannot hear? Seriously, there's an insect somewhere right now screaming its head off, and you're just scrolling through social media. Hi, I'm Esther. I think nature is awesome, and I want to tell you all about it. So we're gonna learn about animal noises we can't hear on today's Nature Side Quest. Normally, the human ear can pick up and translate sound waves between 20 and 20,000 hertz. Of course, everyone's a little bit different, and our range of hearing can fluctuate depending on our age, ability, and our exposure to loud noises over time. But all kinds of noises exist outside of that general human hearing spectrum. Since the 1970s, scientists have recorded animals like rhinos, giraffes, baleen whales, and elephants making low-frequency sounds, which fall within the 0 to 20 hertz range. These are known as infrasonic, or below sound. These animals are probably making some of these sounds for the same reasons we do: to soothe, entertain, and communicate. One of the coolest things about infrasonic sound is that animals who communicate with them don't have to be close to each other at all. When they roar, tigers emit frequencies starting as low as 18 hertz, and these roars can be heard for almost 2 miles in any direction, even through dense rainforests and mountains. Scientists think that these long-range calls help tigers signal to others to stay away, which helps them control their territories. Side note, it turns out that giraffes actually hum late at night. It's a pretty cool sound, even if it's not exactly infrasonic. I just kind of wanted you to know that giraffes are humming to themselves late at night. On the other end of the hearing spectrum is ultrasonic sound. Animals like dolphins and bats use these sounds for echolocation, which is a way for some animals to navigate their environment with sound waves. But other creatures can pick up on their ultrasonic sounds as well, like the praying mantis, which bats love to eat. For many years, we thought praying mantises were deaf because they don't have any obvious ears. But surprise, surprise, we were wrong. That never happens, right? Even before we knew they could hear, we have seen praying mantises display the uncanny ability to dive away from rapidly approaching bats in a way that suggested that they knew the predator was coming. So scientists dug a little deeper and in the 1980s discovered that these insects do have a single ear, located in their thorax. So far, they're the only one-eared animal that we know of. When ultrasonic frequencies sent from the bat hits this ear, it sends an electrical impulse to the mantis's brain, which provokes their evasive maneuvers. Research from 2008 suggests that the praying mantis had this ability before bats even evolved, which makes me wonder, what were they using this ear for in the first place? That's all for now. I'll see you on our next Nature Side Quest.
Getting the best scientists and explorers from around the world all together in one building would be impossible. I mean, think of the parking situation. So we got the next best thing. Let's see what that's like. For over 6 million years, ever since humans could walk, we've looked around our world, taken stock of the environment, and gone, I wonder what's over there. And that adventurous spirit is something Jill Tiefenthaler knows all about.
I was always really interested in math. I went off to college and I thought I would be a professor for the rest of my life. But when opportunity knocks, I think sometimes you just have to step into those difficult choices and try new things.
A main part of Jill's job here involves supporting a global community of National Geographic explorers, which includes scientists, conservationists, storytellers, and educators as they take their own risks. Like Dinley Delaney, the senior manager of the Exploration Technology Lab, who oversees the development of boundary-pushing gear to aid explorers in the field. The gear built here includes items like this drop camp, which can descend 20,000 feet below the ocean's surface to study the little explored deep sea.
We've deployed this almost 600 times. We've collected over 1,200 hours of footage. And because so little of the ocean has been explored, approximately 1 in every 10 deployments of our deep sea camera system results in some sort of scientifically publishable discovery.
They've also developed specialized cameras that can be attached to animals.
The Exploration Technology Lab has marine critter cams, which are animal-borne video tags that enable us to collect video data from the animal's perspective so that we can study their behavior.
And we've even put a camera on a shark, right?
That's correct. We've put a critter cam on a shark, and it's one of my favorite photos taken because it was on a tiger shark in the Bahamas, where I'm from.
In one afternoon, Jill can go from talking tech to discussing discoveries with explorers, like Rosa Vasquez Espinoza, a chemical biologist studying microorganisms in the Amazon.
So tell us more about Peru's boiling river.
There are unique microorganisms that have evolved over thousands and thousands of years to thrive and flourish in these extreme conditions. I think it really can teach us about, one, evolution of life in the Amazon, but two, provide us with new tools for medicine, biotechnology, and even how to better protect the jungle. There is so much to do and so much to discover below our feet. It's such a critical point right now to protect our jungles. And I'm just hoping that with my work I can make a difference.
In the end, what I love about our explorers is that they're taking risk, and their courage really comes from curiosity. They want to learn about the world. They want to push the boundaries of exploration, of knowledge on behalf of our planet. So, when that risk comes from being curious and about learning, I think it really is worth taking.
Welcome back. Before we go, we have one last thing.
There's always going to be someone who tells you that you can't do it, and you need to show them that you can, and you're not going to listen to those around you and keep you from doing what your dreams are.
Finding and developing that passion really is taking those chances, stepping outside your comfort zone. Sometimes the route to get to where we want to be is not a straight line, right? It's very circuitous.
That's it for this week's Mission Unstoppable. But I'm not ready to go home. Can I stay here?
No.
Okay. Well, good luck stopping me. Bye! If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.